Ionic thrusters sound like something straight out of science fiction, like the engines used to power star destroyers and other large ships at sublight speeds. But the reality is, they're real technology being used today by NASA for their current Dawn mission, providing high-resolution images of the dwarf planet Ceres. So if they're being built by the space program, you might assume that they're incredibly technical. Certainly not something you could build in your garage in an afternoon, but you'd be wrong again. With just a high-voltage transformer from a neon sign and a couple of copper pipe fittings in a careful arrangement, you can build your own over-engineered desk fan capable of pushing around a volume of air with no moving parts. You'll need the following parts and tools to build your ionic thruster, and the better part of an afternoon to complete it. Before we begin, a word of warning. This project makes use of uninsulated wiring and a neon sign transformer capable of outputting lethal levels of voltage and current. Make sure the transformer is unplugged anytime you're working around it, and keep any body parts more than 10 inches away from any exposed metal in the project when you have it powered on. And make sure you aren't alone when you're testing the thruster. The first thing you'll need to do is to cut your copper pipe down to 7 1-inch segments. Mark out the pipe at 1-inch increments, and then use your pipe cutter to cut all of the segments. Use a wire brush to remove any residue or other grime from the pipe's outer surface, and then apply a generous amount of solder flux to all outer surfaces. Arrange the segments into a honeycomb pattern and hold the segments together using a thin segment of copper wire. Trim off a 10-inch segment of thick copper wire and coat one end with flux. Place the couplings and wire segment into a fireproof surface and fire up your blowtorch. Heat the coupling for 15 to 20 seconds. Solder the couplings together by applying a small amount of solder to each joint, letting the solder flow between each segment to form the joint. When all pieces have been joined together, heat up one of the joints and join it to the copper wire. Let the coupling cool for 2 minutes before handling, though it may still be quite hot. Place a small scrap of paper over the coupling and use a pencil with light pressure to get a rubbing impression of the coupling. Use a ruler to find the center of all 7 circles and clearly mark it with the pencil. We'll use this as a drilling template for the cathode tower. Cut out only what you'll need of the rubbing and attach it to a piece of wood using tape. Using a drill bit that matches the diameter of your nails, drill holes into each of the centers that you marked. Keep your drill perfectly level as possible. If you have a drill press, be sure to use it. Press fit the nails into the board, but don't press them all the way yet. Wrap each nail head with wire, leaving about 8 inch tailing away from the board. Once done, press the nails in as far as they'll go. Now you need to build a structure to support the copper pipe coupling. Lay the cathode tower on its back and place the pipe coupling over the nail points, with each pipe segment centered over a point. Take a small piece of scrap wood and cut one end to a 45-degree point. Use hot glue to attach it to the copper pipes and then trim the excess wood off so the circles will be centered to the nail points. Attach both pieces of wood to a baseboard using hot glue, making sure to keep them centered, square, and upright. The tube assembly should be about 1 inch from the nail heads. Secure the leads from the transformer to the 2 wire leads from the thruster, making sure everything is unplugged as you do so. With the connections secure, plug in the transformer and variac and turn both on. Slowly increase the voltage output of the variac, feeling for a light breeze coming from the pipe assembly. You may want to hang a tissue in front of the assembly to show the air movement. Your ionic thruster might not get you to Alpha Centauri anytime soon, but it will make for a great science experiment and a conversation starter. It's yet another way to bring the tools of deep space travel into everyone's hands.
If you liked this video, subscribe to our channel or send us a comment on Facebook or Twitter. Be sure to check out our other project videos or visit us on makezine.com.